In this video, we're going to be working on dimensional analysis. So we use this when we want to convert from one unit to another unit. So for example, if we wanted to convert from grams to kilograms. So let's do a problem so we can get comfortable with this. So if we had, for example, 70 grams and we wanted to convert that to kilograms. So a good way to do dimensional analysis is we always want to remember to set it up. We want to do what we want over what you have. So we have 70 grams. So in order to cancel out our grams for our units, we want to do what we want over what we have. So we want kilograms, so we would, for our conversion factor, we would do 1 kilogram, and then we do over what we have, and so that would be 1,000 grams. So that is our conversion factor. So it's always what we want over what we have. And then we see how that ends up canceling out our grams and our units. And then we do the multiplication out and the division, and so you do 70 times 1 and then divided by 1,000, and that gets us our answer of 0.07 kilograms. So that is how you would convert from grams to kilograms using dimensional analysis. So let's try another example. Let's go this time from liters to milliliters. Let's have 0.01 liters. So let's do the same thing. So to set up our conversion factor, we do what we want over what we have. So we know we have liters and we want milliliters. So how many milliliters are in a liter? We have 1,000 milliliters. That's what we want. And then what we have is on the bottom, and that would be 1 liter. And that's our conversion factor. And then we do 0.01 liters times 1,000 milliliters, and then divided by 1. And once again, the same as before, our liters cancels out. And then we're just left with milliliters, which is what is the unit that we want, and we get an answer of 10 liters. So that is how we do dimensional analysis. Now those are very simple examples, and we can get into more complicated examples, which is what we're going to do next. But the key thing with dimensional analysis is always setting up your conversion factor based on what you want over what you have, and that will make sure that your units always cancel out. Okay. So now we're going to work on a harder problem with dimensional analysis that has more steps to it. Now I believe this is problem number 38 in the textbook. So it says, a lap in most tracks that use the English system is 0.25 miles, English lap. In countries that use the metric system, a metric lap is 0.5 kilometers. A champion marathon runner covers a mile in about 5.0 minutes. How many minutes will it take to run an English lap at that speed? And the same for a metric lap. So, for this problem, it's easiest to start off by writing out what the problem gives you. So we did that here. So we wrote that 1 lap is equal to 0.25 miles, which is the English, and we make sure you label which is which. And 1 lap is equal to 0.5, this is kilometers, for a metric lap. And we also wrote out that 1 mile is equal to 5 minutes for the runner. So that is what the problem gives you. So those are our givens. Now, in order to solve this problem, we have to do a lot of dimensional analysis. So for that, we have to always remember to set up our conversion factors, which is what you want over what you have. Now, first we have to start off by using the fact that we know that it takes the runner 5 minutes to run 1 mile. And with that, we know, so let's start with the English lap. So it takes the runner 5 minutes to run 1 mile. So we want to figure out how many minutes it takes the runner to run 1 lap. So we have to make our conversion factor. So we've always been saying it's what you want over what you have, but it can also be what you have over what you want, depending on like the problem, as long as your units cancel out. So for example, in this problem, it's going to be what you have over what you want because our starting unit is on the bottom. So we need the unit of what we have to be on the top in order for them to cancel out. So both our units of what we have then cancel because we have our conversion factor as 0.25 miles is for 1 lap, which is what we have in our givens, because that's the English lap. And then since our units cancel because one's on the top and one's on the bottom, that leaves us with the final units of how many minutes it takes to run 1 lap, which is what we want. So we do 5 times 0.25 divided by 1, which equals 1.25 minutes per lap. And that's for the English. So do we see how we applied the concept of what we want over what we have? But then we did it as what we have or what we want in order to make the units cancel, because one always has to be on the top and one has to be on the bottom in order for them to truly cancel. So you just have to keep an eye out for that. So now let's do the metric lap. So same thing we're going to start off with, 5 minutes per 1 mile, but this time we need to get miles into kilometers because that's what the metric lap unit is in. So we need miles to be on the top of our conversion factor in order for it to cancel out. And we know that there's 0.621 miles for 1 kilometer. So then that's our conversion factor. So miles cancels out. And then we now need kilometers to cancel out so then we can get 1 lap. So we have this. This is straight from our problem because 1 lap is in the metric system is equal to 0.5 kilometers. And then our kilometers cancel, leaving us with our units, final units of minutes per lap. So we do the multiplication across of 5 times 0.621 times 0.5 divided by 1 is equal to 1.6 minutes per lap. And that's for metric. And so that's how we do that problem. So that was a harder problem for dimensional analysis. But as long as you keep your conversion factors organized and your givens organized and you make sure that your units on top always cancel out with what you have on the bottom, you should get the hang of it.